Why wavelet analysis is effective? What is the special behavior of a wavelet? Already we've gone through all the points. Just overview about this we are going to have here. Why is wavelet analysis is effective? Wavelet expansion and wavelet transform has proven to be very efficient and effective in analyzing a very wide class of signals. That means we can apply some of the signal areas. We can say that biomedical signal processing, radar signal processing, speech signal processing, image process. So many ways we can use this wavelet transform and phenomena. Why is this true? How can you justify this effectiveness? What are the properties that give this effectiveness? One is the size of the wavelet expansion coefficients AJK in or DJK in drop off rapidly with J and K for a large class of signals. The number of coefficients, how many we are using, going to drop off rapidly. This property is called the being an unconditional basis, and it is why the wavelets are so effective in signal and image compression, denoising and detection process. Unconditional basis. In Fourier series, conditional basis, either the basis function to be sine or cos. Here there is no such a restriction, so you can use sharp varying wavelets also. That will give you AJK DJK drop off rapidly with J and K for a large class of signals. Donoho showed that wavelets are near optimal for wide class of signals for compression and denoising and detection purpose. Then second point, the wavelet expansion allows a more accurate local description and separation of a signal characteristics. Local description, not a global description, local description. In Fourier series, in the entire period you are going to calculate how the frequencies are existing, what frequencies are existing. But there is no any time reference in Fourier series. In this case, local description. At a particular time, what is the frequency existing? A Fourier efficient represents a component that lasts for all time. In the entire time, what are the frequency components are existing? And therefore, temporary events must be described by a phase characteristic. So, all time existing frequency components are represented by magnitude response, and temporary events are described with a phase characteristic that allows cancellation or reinforcement over large time periods. A wavelet expansion coefficient represents a component that itself local and is easier to interpret. The wavelet expansion may allow a separation of components of a signal that overlap in both time and frequency. The third point is wavelets are adjustable and adaptable. Already we discussed by adjusting, by increasing, varying K and J parameter, we can get more number of wavelets, because there is a not just one wavelet, they can be designed to fit individual applications. They are ideal for adaptive systems that adjust themselves to suit the signal. Already we discussed that by translation and scaling we can generate a fast varying wavelets also. The fourth point is the generation of wavelet and the calculation of discrete wavelet transform well matched to the digital computer, because discrete wavelet transforms are available. AJK coefficients are nothing but discrete wavelet coefficients. We will later see that defining equation for the wavelet uses no calculus. There are no derivatives or integrals, just multiplications and addition operations that are basic to the digital computer, so that wavelets are well suited for digital environment. With this, we will wind up the session.